This lesson is pretty much a transplant from Chapter 4. We're writing linear functions, and remember, a function is a relationship that pairs one input with one output. A linear function is a function whose graph is a non-vertical line. A linear function can be written in the form y equals mx plus b. So we're going to be writing our formulas today in slope-intercept form, and we're just calling them functions instead of equations. And you might say, well, then how come we're doing this lesson? Why are you calling it a function? And back in the beginning of Chapter 6, I told you that you will be using the terminology about functions all the way into post-high school or, advanced high school lessons. So I want you to see that while the directions might be phrased differently, it's really asking for the same thing. So the directions here in example 1 say use the graph to write a linear function that relates y to x. All that means write an equation in slope-intercept form. So in order to do that, we need the slope and we need the intercept. Well, the slope is up 3, right 2, so that's a slope of 3/2, and the intercept is right here at 0, -3. So the formula is y equals 3/2 x minus 3. And the second example, I need the slope and I need the intercept. So slope is down 1, so that's -1, right 2, so the slope is -1/2. And the intercept is right here at 0, -1. So the function is y equals -1/2 x minus 1. That's all great, but when you get to an example like in example 2 where you don't have a graph, you need to come up with another technique. So our directions are the same, but now we're using a table to write a linear function that relates y to x. So if you had a piece of graph paper handy, you could plot the points and count the slope, but that's a lot of work. What I want to do is use this formula that we talked about back in Chapter 4, which is the slope formula. I'll put it on your paper, and I want you to do that as well. The slope formula is y2 minus y1 over x2 minus x1. And we know that m stands for slope. This is the formula, and then you just have to identify the parts. Now, when you have a table, you can pick any pair that you want to plug in for x and y, but you have to, obviously, there are certain requirements. You can't just randomly pick them. So I'll pick this pair, and it doesn't matter. I'll pick this pair. I just randomly picked 2 pairs. So in this example, I have x1, and if that's x1, that's y1. And then this will be x2, and that will be y2. And we talked back in Chapter 4 that it doesn't matter who you call point 1 or point 2, but the x values have to be x values, and the 1s and 2s have to stay together. So now I just take these pieces that I identified and plug it into the formula. y2 is 3, y1 is 7, x2 is 0, and x1 is -2. So now I have to simplify. 3 minus 7 is -4. 0 minus -2 is 2. So that gives me a reduced slope of -2 over 1, or just -2. The intercept is right here at 0, 3. So I have the slope, I have the intercept, and now I just have to put it together in a formula. Y equals -2x plus 3. If you want to try the second example on your own, go for it. If not, let's do it together. I'm going to pick any 2 random points. I'll pick this one and this one just because everything's positive and that's friendly to work with. So now I have to identify. This will be x1, this will be y1, x2, y2. So the slope is 2 minus 2 over 1 minus 0. So that gives me a slope of 0 over 1, which is 0, a slope of 0. The intercept is right here at 0, 2. And I know that it's the intercept because it has an x value of 0. That's how I knew this was the y-intercept as well. So 0, 2. So y equals 0x plus 2. Do you remember back from chapter 4 how I encouraged you to write this? I encouraged you to write it as just y equals 2. But 0x plus 2 is fine, although most people don't write that. All right, let's move along. You are controlling an unmanned aerial vehicle, or UAV, for surveillance. The table shows the height in thousands of feet and the UAV x minutes after you start its descent from cruising altitude. Letter A. Write a linear function that relates y to x. Interpret the slope and y-intercept. So, in order to write a linear function, I need the slope and the intercept, and then I have to interpret what they are. So, since I don't have a graph, I'll use my formula, and I'll pick these first 2 points. It doesn't matter which two you pick. This is x1, this will be x2, this will be y1, this will be y2. So, using the slope formula, it is 60 minus 65 over 10 minus 0. So that is negative 5 over 10, which as a reduced slope is negative 1/2. The intercept is right here at 0, 65, because that's where the x is 0. So I have a slope of negative 1/2 and an intercept of 0, 65. So the formula is y equals negative 1/2 x plus 65. That's not all they want, though. They also want you to interpret the slope and intercept. So what does negative 1/2 mean? So negative 1/2 means, this is me interpreting the slope, the UAV moves down 1,000 feet, because it says the height is in thousands of feet up here at the top, for every 2 minutes. And now I have to interpret the intercept. The intercept is 0, 65. 0, 65 means the UAV starts 65,000 feet up. I would like you to pause the video and graph the linear function that we just did. Be careful of your scale. And when you're ready, play the video and I'll show you my graph. Alright, a couple things I want to mention about this graph. First is that I went by tens on both axes. Now I had to go by tens on the y because I tried to go by fives and it just didn't fit. So I said, I guess I'll go with tens and I'll just have to plot in the middle of a box. So then when I went to count the slope, down 1, right 2, it wasn't down 1. It was really down 10, right? Because this was going by tens. So it was hard for me to count the slope since I was going by tens, but the slope goes by ones. So I got really confused as to how many I should really move. So when that happens, if you have a situation that happens like this, then the best way to avoid it is to make them both go by the same scale. When they both go by the same scale, then you can go down 1, right 2. If they're going by different scales, like if I did this by tens and this by ones, I couldn't do that. I couldn't just go down 1, right 2. So in order to be able to use this slope, I had to make them both the same. So if that helps you in the future, please remember it. Then I plotted a couple more points so I could get a more accurate line, and I labeled it with the equation. Last thing we have to do for this example is we have to find the height of the UAV when you stop the descent after 1 hour. Now 1 hour is 60 minutes. Whoops, that's very sloppy. So I will plug in an x value of 60 into the equation. Y equals -1/2 times 60 plus 65. If x stands for minutes and y stands for height, if I plug in 60 minutes, I can find the height. So y equals -1/2 times, -1/2 times 60 is -30. So that gives me a y value of 35. Remember, it's in thousands, so that's 35,000 feet. All right, last example together. The earnings, y in dollars, of a nighttime employee working X hours are, I think that says is on your paper, sorry. Is represented by the linear function y equals 7.5x plus 30. Remember, this is nighttime. The table shows the earnings of a daytime employee. And here's the table. Which employee has a higher hourly wage? Now, this is another way of asking about the slope. They're asking about the person's rate. So, I know the slope of nighttime because it's in the formula, it's 7.5. So now I need to find the slope of daytime. So let's use that slope formula again. M equals, I'll pick this one and this one just because they're the first two. And I should label, this will be x1, this will be y1, this will be x2, that'll be y2. So now I plug in 12.50 minus 25 over 1 minus 2. So that's -1250 over -1. Reduce that down and you just get the number 12.50. So the daytime employee's slope is 1250. So clearly the daytime employee is a higher hourly wage. Write a linear function that relates the daytime employee's earnings to the number of hours worked. So, I know the slope. This is the first example where we don't have the intercept in the chart. Remember, the intercept starts with 0, comma something. So I don't have that in the chart here. But if x is 0, then I can backtrack. So if I know that every hour this person is making $12.50, let me use some logical reasoning skills and say, well, every hour they're making $12.50, so what would they make at 0 hours? Well, at 0 hours, they would make 0, so it would be 0, 0. In the same coordinate plane, graph the linear functions that represent the earnings of the two employees. So first I have to put it all together. Y equals 12 I'll just write 12.5x. You could write 12.50x plus 0, but nobody writes that, so don't do it. So y equals 12.5x. So this is the daytime, and then we have the nighttime up top. That's over here, 7.5x plus 30. So let's graph. Make a grid, and I'm going to stay in the first quadrant because the people are not making negative money and they're not working negative hours. I have to figure out a scale to go by. I could probably go by ones on the x-axis, but it looks like I might have to go by something large on the y-axis. So let's do 15s. Okay, that should be a good labeling for now. So now I'm going to plot the daytime first. So daytime gets 1250 every hour. So 0, 0 is on the graph. Then they make 1250 in the first hour, so they're almost here. Almost at 15. Then they get up, then they make another 1250. So I think I maybe just need to make a chart for this. So 0, 0. Then 1 is 1250. Oh, well, duh, there is a chart. It's just off the screen. Silly me. Then 2 is 25. 3 is 37.50. And I'm making this chart. I'm just copying it from up above. I just didn't see that. And do they have 4? Yes, they have 450. So I'll put that on as well. Okay, this is the daytime employee. And I'll write the equation, y equals 12.5x. All right, now we go to the nighttime employee. Now the nighttime employee starts with $30. So they start here, and then they make $7.50 every hour. So they start at 0.30. And then after 1 hour, they make $7.50, so that's $37.50. So that's a little over here. Then they make another $37.50. So add $37.50 to that. Or I'm sorry, add $7.50. And they make $45. Add another $7.50. Then they're at $52.50. And I'm doing this because the graph doesn't go by the same scale like we saw in that other example. And then they make 60, so that should be good for now. So you see that the daytime employee is making a little bit less at the beginning, but then once they work for 3, 4, 5, about 5.5 or 6 hours, depending on how accurate my line is, then the daytime employee starts making more money. So that's what I'm going to do right here where it says to interpret the graphs. I'm going to write a sentence about what I'm noticing. So before, or I should say in the beginning, I'm going to abbreviate, the daytime employee makes less, but then around 6 hours into work, the nighttime employee starts making more. All right, if you have any questions, write them down and ask me when you come to class.